number 15. So this section that we're in is all just simplifying. They're asking us just to simplify the trig expressions, and you use trig identities and algebraic operations to do that. Remember, I'm going to give you a formula chart, okay, that has all of your identities listed. You don't have to have all of these memorized. Remember, we've done reciprocal, quotient, Pythagorean, odd and even, and cofunction. Okay, we did not cover sum and difference. That's not going to be on there. Okay, but you'll have a sheet like this with all the identities listed. Okay. All right, so one of the strategies that we talked about a lot in our notes, in our practice, the past couple weeks has been put everything in terms of sine and cosine. Okay, so when I do that in this denominator, what's the relationship between sine and cosecant? Those are reciprocals of each other. So you may or may not need to write this out, but if you replace cosecant with 1 over sine, what happens here? Yeah, those reduce. That's just a 1 now. So it's not a fraction anymore. Do y'all see that? Okay, you may not need to write that step down. You may remember when you multiply reciprocals, you get 1. So the denominator is just an understood 1. Okay, so I don't even have to worry about the denominator anymore. I just need to focus on the numerator. Okay, well, in the numerator, I can rewrite cosecant as 1 over sine there as well. The difference is in the numerator, those are not being multiplied, they're being subtracted. So you can't just reduce those. Okay, this is subtraction, not multiplication. Okay, if I want to see this as a fraction, I can put it over 1. To add or subtract fractions, what do I have to have? Common denominator. So I can change this 1 to sine of x by multiplying by sine of x. And if I do it to the denominator, I have to do it to the numerator. Okay, so my new common denominator is sine of x. And in the numerator, I'm going to have 1 minus, what's sine times sine? Sine squared. What is 1 minus sine squared? That's a Pythagorean identity. So remember the Pythagorean identities, there's 3 of them listed this way right here, but those can be rearranged. Okay, so 1 minus sine of x, that's if this sine of x was subtracted over here, we'd have 1 minus sine of x, and it'd cancel over here. And so that's equivalent to cosine squared of x. So I can replace that. Okay, so I did that substitution there. What do y'all think about this though? What could I do from here? I do see a quotient ID, but what's different about this one? The numerator is squared. Is the denominator? No. So let's think about this. Cosine squared literally means cosine times cosine, right? And it's over sine. So that is a quotient ID, the cosine over sine, but there's an extra cosine in the numerator. So that still has to be there. So cosine over sine is cotangent, but I've still got cosine. So that's as far as I can take this one, but I at least get it without a denominator. I get it to where it's not a fraction. Okay. That's as much as I can simplify that one. All right. 16 is the next one. Oh, you know what? I just realized there is two 15/16s. Oh, that should be 7. So all those are going to be off. Oh, well. We'll do them all, but the numbering's off. No, you don't have to worry about fixing it. I'm fixing it on my Word document, so next time I print this, it's not messed up. Okay. You don't have to worry about changing the numbering on yours, but I just wanted to on my original. All right, so here I'm going to use the strategy of putting everything in terms of sine and cosine. So cosecant squared, I'm going to use the reciprocal identity. In tangent squared, I'm going to use the quotient identity. So cosecant is 1 over sine. So this would be 1 over sine squared. And tangent is sine divided by cosine. So this will be sine squared over cosine squared. Okay, so then what happens? Yeah, you have sine squared in the numerator and denominator that reduces anything divided by itself. That's just a 1. So now this is just 1 over cosine squared minus 1. Okay, so now I'm going to work backward. Instead of getting everything in terms of sine and cosine, I'm going to get this, I'm going to go backward and change this out of cosine so that I get rid of the fraction. So that would be secant squared. Now that right there is a Pythagorean identity. Secant squared minus 1. What's that equivalent to? Tangent squared. Okay. And remember, the way that I'm going through these are not the only correct way. You may have taken a different path along, like maybe you started out the same, but then veered off. Okay, like maybe here, instead of changing this to secant squared, maybe you changed this to cosine squared over cosine squared to be able to combine the fractions. And you went from there. And eventually you could still end up in the same place. Okay? This is just the way that my brain is taking me through them. Yours may have taken a different path and still gotten you to the same destination. All right, so the next ones on your original, it says 15 and 16 again. There's a typo in the numbering. All right, so secant and cotangent can both be rewritten in terms of sine and cosine. It's again that's going to be a reciprocal and then a quotient identity. So secant is 1 over cosine. And cotangent is cosine over sine. What happens there algebraically? The cosines reduce. Good. So I'm left with 1 over sine, but I don't want my answers as fractions or with denominators. So what can I change that to? Cosecant. That's a reciprocal ID. All right, now this next one, again, on your paper, it says 16 again. This was the last one I found that had a mistake, a typo in it that was not intended. I want you to change this secant to cosecant. Okay, so fix that on your papers. Gonna make this much easier to simplify, make more sense. Okay, so this, a different color, I used orange on this page, is what type of identity? That's a cofunction. If you look at your list of identities, remember cofunction, those are the ones here where you're using the complementary angle. Pi halves minus x is complementary to x. Those two angles, it's like the opposite two acute angles in a right triangle. Okay, so cofunction, the ones that go together are the ones that have the same word, just with co. So sine and cosine, tangent and cotangent, secant and cosecant. Okay, so you can see there, cosecant of pi halves minus x is equal to secant of x. Y'all see that? Okay, so I'm able to replace that using the cofunction identity. Okay, and there's still a minus in front of it, and then there's all this still here. Now, both of these terms, this one minus this one, what do they have in common? They both have secant, so I can factor that out. That's going to leave me with cosine squared of x minus 1. Remember, when you're factoring, you're dividing it out. Secant divided by secant will leave you with a 1 right there. Now that is a Pythagorean identity. Cosine squared of x minus 1. What would that be equivalent to? Let's look at our identity. Okay, so the identity, this is the Pythagorean here, sine squared plus cosine squared equals 1. So if I want the cosine to be positive, okay, and then this is going to be minus 1, that means this minus 1 has been moved to the left. So I would have to move sine squared of x to the right. So how would I move that sine squared x over? What would it become? It'd become minus. So that's negative sine squared. Okay, so be careful with your signs. Okay, so that's negative sine squared of x. Now, secant can be rewritten as 1 over cosine. So if I just do some simplifying, again, this is like sine of x times sine of x, right? Sine squared over cosine. We know the sine over cosine is the quotient. That extra sine of x is still there, and then it's negative. And that's as far as we can take that simplification. Okay with that one? All right, let's look at the next couple. All right, so secant over cosine of negative theta. So when you have a negative angle as the input, you should be thinking about your odd even identities right here, these. Okay, if it's cosine and you input a negative angle, the output does not change. It's still just cosine of x. But if it were sine or tangent or one of their reciprocals, it would come out negative. Okay, so cosine and its reciprocal secant are even functions. Okay, you input a negative, your output is unaffected. But sine and tangent and cosecant and cotangent are odd functions. When you input a negative, the output changes sign as well. Okay, So in this case, it is cosine. So that means that negative can just drop. It's going, cosine of negative theta is going to be the same as cosine of theta. So you don't even need that negative there. Just rewrite it as cosine theta. So the negative drops. That right there is an odd even identity. This one is an even function. Okay. Then secant can be rewritten as 1 over cosine. And we flip and multiply because we don't want a fraction within a fraction. So we're multiplying by 1 over cosine. And that becomes 1 over cosine squared, which in turn, to get rid of the fraction, we do the reciprocal, which would be secant squared. So we used an odd even identity, we used a reciprocal identity, and then we used another reciprocal identity. Everybody all right with that one? All right, now here is another odd even identity, but sine is an odd function. So that's going to come out as negative sine of theta. Okay, that one does change the output, the trig function, to negative. And then I can rewrite cosecant as 1 over sine. Now the sine of theta is still going to reduce. It's still going to cancel out in the numerator and in the denominator. But instead of a 1, what do I have? A negative 1. Good. Okay. Right. 21, or on your paper, I think it says 19. I have 2 fractions trying to be added. What do I have to add fractions? Okay, and both of them have tangent. So the only thing missing here is the times cotangent. So I can add that pretty simply by just multiplying by cotangent. Okay, so that's the first thing I'm going to do, is get a common denominator. When I do that, in my numerator, I get 1 plus, and then that becomes cotangent squared, right? Now the denominator is now tangent times cotangent. Now, cotangent and tangent are reciprocals, right? So I could rewrite the cotangent as 1 over tangent in that common denominator. That cotangent got replaced here. What's that going to do in my numerator? Or excuse me, in my denominator? Yeah, that's just a 1 now. So my denominator is an understood 1. No more denominator. You don't have to rewrite it this way and show the reducing if you understand that multiplying reciprocals gives you 1. Okay, now the numerator, which it's not really a numerator anymore because there's no more denominator, this 1 plus cotangent squared, that is a Pythagorean identity. 1 plus cotangent squared is cosecant squared. All right, and then 22, again, on your paper, I believe it says 20. I'm going to use the strategy of make everything in terms of sine and cosine. Okay, so all three of those terms can be changed to terms of sine and cosine. Cosecant, you use the reciprocal function, it's 1 over sine. Tangent, we use the quotient identity, it's sine over cosine. And secant is 1 over cosine. That's the reciprocal identity as well. We still have -1. What happens here when I'm multiplying these three fractions? Can I reduce anything? Yeah, the sign in the numerator and denominator reduce. So I'm left with 1 over cosine squared -1. Now 1 over cosine squared is secant squared. What is secant squared -1? It is tangent squared. So I used reciprocal IDs, quotient ID, reciprocal ID again, and then Pythagorean ID. All right, last two in this section. The bottom of that page, it's 21 and 22 on your paper. All right, this is already in terms of sine and cosine. What do both of these terms have in common? They both have a sine theta. So I'm going to try factoring. If I factor out sine of theta, what's that going to leave me with? If factoring is dividing, right? So sine divided by sine, that's going to leave me with a 1 there for that term, minus. And then when I divide there, it reduces to a 1 times cosine squared. So cosine squared. Now 1 minus cosine squared, that's a Pythagorean identity. That is sine squared. And then I've got sine times sine squared. What would that be? Sine cubed. Good. So I factored, used Pythagorean identity, and then simplified. All right, last but not least for this section, there's another one, it was number 10, that was similar to this in style. You have a binomial, that means a two-term expression, right? Times a binomial. In algebra, when you have a binomial times a binomial, what do you do to simplify this? What's that process called? If I want to get rid of these parentheses, what would I have to do? Say it a little louder. This is factored form. When it's separated like this, this is factored. So it's like the opposite of factoring. Right, it's distributing, right? But it's a binomial. So I'd have to distribute the cosecant to both terms here, and then distribute the cotangent to both terms, right? So you may think of that as double distribution, or there was another little name for it. FOIL. First, outer, inner, last. So you multiply the first term of each, the outer terms, the inner terms, and the last term of each. Now remember that? FOILing in algebra 2. Okay, you don't have to remember that acronym. You can just think of it as double distribution. So the cosecant times 1, that's just cosecant. Cosecant times negative cosine. So that's going to be minus cosecant cosine. And then cotangent times 1, so plus cotangent. And then cotangent times negative cosine. That's going to be minus cotangent cosine. Whew, seems like it made it more complicated. But let's try that strategy now of changing everything to sine and cosine. So cosecant is 1 over sine. Cosine is already cosine. Cotangent is cosine over sine. Cosine is already itself. So far, so good. So I changed all the cosecants to 1 over sine. And I changed all the cotangents to cosine over sine. Now, what is happening here in the middle? Isn't this just cosine over sine? So negative cosine over sine plus cosine over sine. So what happens? All that middle cancels each other out. Because you have a negative and a positive of the same term. That's 0. So I have 1 over sine minus, what's cosine times cosine? Cosine squared over sine. Now I've got a common denominator, so I can go ahead and combine these. So it's 1 minus cosine squared over sine. 1 minus cosine squared is, that is sine squared. The Pythagorean identity. And what happens here? Yeah, the sign from the denominator reduces with one of the signs in the numerator. So you're left with just sine of theta. You feel okay about that? All right, so the majority of the review was just practice simplifying, because that's the majority of the test, is just simplifying. Now there are questions, more like the front page of the review and this last page, where maybe the proof is shown and you have to say if a mistake was made, or you have to say what step was taken. Okay, and then like the first 4 as well, where you're given a value of one of the trig functions or 2, and you have to find others still using identities. So if you need help with that front page, remember that's on a separate, you can watch that other video, the first video. All right, but let's go ahead and look at the last page. All right, so you're given this identity. And you are asked, man, this all in on one. So we want to fill in what's happening each step and then answer these questions. All right. So it starts out here. This is what we're trying to prove. We are trying to prove that this simplifies to just tangent of x, that it's equal to tangent of x. Okay, so the first thing that I see happening is they have replaced cosecant with 1 over sine and secant with 1 over cosine. Why did they do that? How did they do that? What's the reason? Those are reciprocal IDs. That's how they're able to do that. So that's step 1. Okay. Now the next thing I see is instead of dividing by those fractions, they're multiplying by the reciprocal. Y'all see that? So instead of dividing by 1 over sine, it's multiplying by sine over 1. Instead of dividing by cotangent over cosine, they're multiplying by cosine over cotangent. So that's not an identity, that's an algebraic operation. You could write that as like keep, flip, change, or multiply by reciprocal of the denominator. Okay, but that is just an algebraic operation. That is not a trig identity. Now, once they've done that, they have the sine times sine is now sine squared. Cosine times cosine is now cosine squared. So that's just simplify. They just simplified there. Still no identity used in that step. Okay, so then the next one though, the change I see is cotangent is now 1 over tangent. What's that? That's the reciprocal ID again. And then they do the same thing. They flip and multiply by tangent. So again, multiply by reciprocal of denominator. All right, so then from there, they have both terms had tangent in them. And now the tangent is outside the parentheses. What happened? What's that called? What did they do? When you take out something that the terms have in common, put it outside parentheses and put in parentheses what's left, what's that called? Factoring. So they factored. Then they did a replacement here. Sine squared plus cosine squared is 1. What identity is that? That's Pythagorean. And then they just multiplied by 1, which is just tangent, so that's just simplifying. Simplify. So the questions are, what algebraic, I'll be here for tutorials. I'm going to finish this video since it's the last part. What algebraic operation was performed in step 2? Okay, multiply by reciprocal of denominator. Okay, what algebraic operation was performed in step 6? Factor. And then were each of these identities used? If so, in what step? So reciprocal ID was used in step 1 and 4. Steps 1 and 4. Quotient ID, look at our, none of them were quotient ID. Or you just say no, it's not used. Pythagorean ID was used there in step 7. And cofunction and odd even identity, neither of those were used, so those are both a no.